All right, so then this particular problem, they're asking us to simplify, rewrite, or get rid of the fraction. So initially, there's not much we can do. We can't substitute, we can't split, we can't do much, right? And so we're going to rewrite it in terms of sine and cosine. So I have cotangent x in the numerator, and the denominator, secant, is 1 over cosine x. And again, there's many ways to do this. This is just one of them, okay? Secant x is 1 over cosine x minus tan of x. Tan of x is sine x over cosine x. And now notice how they both have cosine in the denominator of the denominator, right? And so I can put them together as 1 minus sine x over cosine x. The 1 minus sine x, it is not an identity because it's not squared, so we can't substitute that. I'm gonna, however, so we have a fraction divided by a fraction, right? To fix that, or to get rid of the fraction, I'm gonna multiply by the reciprocal of the denominator, right? So here's my denominator, I'll call it D for denominator, and I have my numerator, which is cotangent. So I'm going to rewrite it, my numerator, cotangent, in terms of sine and cosine. So cotangent is cosine x over sine x times the reciprocal of the denominator. So the reciprocal of the denominator is going to be cosine x over 1 minus sine x. And so when we multiply those two things together, I end up with cosine squared x divided by sine x times 1 minus sine x. And then from here, we can work with the top, right? So even though we still haven't gotten rid of the fraction, it's kind of looking like maybe it's a little bit more difficult, but we accomplished the first goal, which was to turn everything into terms of sine and cosine, and then we can work from there. So cosine squared x can be substituted in for 1 minus sine x squared over sine x times 1 minus sine x. And so we can recognize this numerator is a perfect square. And so if I were to factor it, my factors would become 1 minus sine x times 1 plus sine x all over sine x times 1 minus sine x. Now, even though I have it kind of got a little lengthy, I can cancel this 1 minus sine x times the 1 minus sine x in the denominator because they are the same term, right? And so then I'm left with 1 plus sine x over sine x. Now we still haven't gotten rid of the fraction, but since I only have one term in the denominator, I can split these up. And so when I split it up, I get 1 over sine x plus sine x over sine x. The 1 over sine x is cosecant x, and then sine x over sine x is 1. And that's what I end up with. I can't go any further because there's no more simplifying after this, right? And so that's going to be my final answer for that particular problem. So moving on to this last section. So again, they're asking us to prove this identity. So in other words, make the left side look like the right side. Now, if you notice, they both have the same terms. They both have cosine squared theta, or they both have cosine, they both have sine. So we can't really rewrite it in terms of sine and cosine. And so it's a little bit tricky to see, but notice how here that's to the fourth and that's to the fourth. Now, if we can somehow factor that, then it'll help me, right? And so when we factor this, we get cosine squared theta minus sine squared theta times, it's a difference of square, right? So it's another perfect square. It looks weird because it has a power of 4. But if we make the original one square and square, then it'll work out. And so we have cosine squared theta plus sine squared theta. Now we're starting to get somewhere. So if I were to multiply these out, I should get the original, right? So if I'm quick check, so cosine squared is cosine 4, negative sine squared, sorry, back up. So cosine squared times sine squared, we get the positive version of that. But then when you multiply a negative sine squared times cosine, you get a negative. So they will end up canceling out. And then the last one is multiply negative sine squared times sine squared gives you negative sine to the 4. So we have our factors. And so now from here, we should recognize that this cosine squared plus sine squared is indeed the trig identity. And so this whole thing becomes a 1. And so now we just have cosine squared theta minus sine squared theta times 1. Well, when you multiply by 1, you get the same thing. And so we end up with cosine squared theta minus sine squared theta is equal to cosine squared theta, or in other words, the right side. And so that proves that it is indeed an identity.